say we have an elemental composition C3H6, and let's say we have propane, and we are comparing propane and cyclopropane, then we are talking about ring chain isomerism, because in one case it is an open chain because carbons are connected this way. In another case it's a ring because the carbons are connected that way. So in bond line notation we don't show hydrogen, so let's not worry about that. Let's move on to another example. So let's say we are comparing, let's say we have cyclobutane and let's say we have methyl cyclopropane, then also we are talking about ring chain isomerism. Let us say we have an elemental composition like C3H6O. We can definitely have acetone as one of the isomers, and we can also have cyclopropanol. Now here is the question, are they examples of functional group isomerism or ring chain isomerism? So here comes the order. We have an order among the constitutional isomers. So the order goes like this. The order is ring chain isomerism first, and then tautomerism, and then functional group isomerism, and then metamerism, and then chain isomerism, and then last is position isomerism. So in an exam, if they are asking whether these two molecules are examples of functional group isomers or ring chain isomers, you have to choose the ring chain isomers. You should not select it as functional group isomer. They are indeed functional group isomers, but we have an order here. So the order is RTFMCP. That's the order you should follow. Even if you are, let's say if you are comparing, let us say you are comparing propanol, this is propanol with cyclopropanol, then also you are talking about ring chain isomers, not functional group isomerism. But on the contrary, if you are comparing these two, let's say if you are comparing acetone with propanol, then you are talking about functional group isomerism, because there are no rings here. So in one case you have a keto group, in another case you have an aldehyde. So here you are talking about functional group isomerism. But if you are comparing acetone with cyclopropanol or propanol with cyclopropanol, then you are definitely talking about ring chain isomerism. So this one you need to be very clear about it. Let's look at more examples. So let us say we have compounds like this. This is orthoxylene, this is metaxylene, yeah, and then this is paraxylene, okay, orthoxylene, metaxylene, paraxylene. So my question to you is, are they examples of ring chain isomerism? No, they are not examples of ring chain isomerism, because the common thing here is this one, including the methyl group. That's the common thing. They are good examples for position isomerism. They are not ring chain isomers. Let us say we have C5H10. Here also we can have ring chain isomerism. Cyclopentane, we are comparing cyclopentane with let's say 1-pentene or 2-pentene, then you are talking about ring chain isomerism. But if you are comparing 1-pentene with 2-pentene, then you are talking about position isomerism. Okay, if you are comparing cyclopentane with 1-pentene, cyclopentane with 2-pentene, then you are talking about ring chain isomerism. But if you are comparing 1-pentene with 2-pentene, then you are talking about position isomerism. Okay, we can also, let's say, we can also take this as an example. Let's say we have cyclohexane, and then we can write 1-hexene. Yeah, so they are examples for ring chain isomerism.